Hi folks, Mr. Long here with a podcast on analyzing exponential functions with written descriptions. So here's a scenario where we have a population of Belleville growing at 1.4% per year, population of 50,000 in 2010. So here's the general form of our equation. General form of our equation is right there. A times 1 plus or minus p is percent over 100 to the exponent of x plus c. C would be a horizontal asymptote. And in this case, in this question, we're going to have f at x equals 50,000 times by 1 plus, because it's growth, of 1.4%, which is represented as 1.4 divided by 100 to the exponent of x. And there is no horizontal asymptote in this case. It's just how many people, and there's growth with respect to the whole population. There's not a segment that is not growing. So one of the ways that I could shorten that is to write it as 50,000 times by 1.014 to the exponent of x. And one of the problems I did in class today is that I used 50 instead of 50,000, but I think you need the 50,000 to get good enough data. So we're going to set x equals 0 to the year 2010 because that's what's given. So that's our 0 year. So let's take a look at some of the things that we can do here. Look at our chart. So I'm going to rewrite that equation here. F at x equals 50,000 times 1.014 to the exponent of x. So we know the exponent of 0 is 1, so that's 50,000. And then what I'm doing is substituting in exponent of 1. So 50,000 times 1.014 to the exponent of 1, which is 50,700. And then I can move up again and multiply by 1.014 yet again, which is 51,410 if I round properly. And then the third one would be 51,410 times by 1.014, or 1.014 to the exponent of 3, which would be 52,130. So now I do my differences. 52,130 minus 51,410. So it grew by 720 there. 50,700 minus, 51,410 minus 50,700, which is 710. And then this is 700. And then we do our ratios. 720 divided by 710 equals 1.014. 710 divided by 700 . 1.014. So if you look, we've got our ratios, and our ratios, it's very clear, the ratios are the 1 plus or minus p-value. So that is your common ratio. So that will help you in terms of your equation if you just had a table of values. Okay, so, and if you look at it then, in this case, there's your A value, right there, and there is your 1 plus or minus, that should be P over 100. plus or minus p over 100. Okay, so what was the population in the year 2000? Well, our formula is f at x equals 50,000 times by 1.014 to the x, where x represents the years after 2010. So the year 2000 means x equals negative 10. It was 10 years ago. So substitute in negative 10, get your answer. How long will it take the population to triple? Well, triple 3 times 100 and 3 times 50,000 rather. 3 times 50,000 is 150,000. So we're going to say 150,000 equals 50,000 times 1.014 to the x. I'm going to divide both sides by 50,000. And that leaves me with 3 equals 1.014 to the exponent of x. So now we have to do guess and check to figure out x. And we're going to get a value for x. And so x equals, you do that guessing and checking, and then you'll be able to write a new equation that's going to be f at x equals 50,000 times by 3 to the exponent of x over some number that is the tripling time. Okay, I'm just going to the next problem, part C. And in it, we need to find the intersection point. So we're looking at when Quinte West, and let's look at this. Will Quinte West ever catch up? So if you look at this, Quinte West starts at 44,000, and it's growing at 2.7%, whereas Belleville's at 50,000, it's growing at 1.4%. So that really would mean that eventually Quinte West is going to catch up to Belleville at some point. So let's take a look at how we might do this. I'm going to focus on dividing both sides by 44,000. In which case we're going to get 1.027 to the x equals and that will equal 1.3 sorry folks, 1.136 to the x. 1.136 times by 1.014 to the x. And then what I can do is to divide both sides. The 1.014 to the x. And that divides out. And 1.027 divided by 1.014 is, so 1.013 to the x equals 1.136. And then you're going to want to guess and check that until you can get a value of x. So just to get you started on scenario 2, what I'll do is create an algebraic representation for the relationship. So we've got a $1,600 computer that's depreciating by half every 10 months. So it looks like f at x in this case. So it's a wait a second, it's a $1,600 computer, but there's a buyback of $300. So then the question is, how much of the computer can actually depreciate? Well, it can only depreciate from 1600 to 300, so that means only 1300 of the computer is available for depreciation. So 1300 divided by, or multiplied by, so it's got by half every 10 months. So that's x over 10, plus we've got this $300 guaranteed buyback. So that doesn't depreciate, right? You're guaranteed $300 when you're done using it. It's almost like a lease scenario where you pay $1,600, but you get guaranteed to get $300 back at any time up to 8 years. So the 8 years doesn't really play a role in the equation. It just doesn't really play a role in the equation. It just that's an X there. So when you go about doing this, and you could of course represent it this way, 1300 times by 1/2 to the 1/10 all to the x plus 300 if you want to represent it in terms of percents. And I will let you do that. And then what you need to do is, again, to go through and work through each of these questions in turn, which are very similar to the other side of the page. Okay, so that's how you do the second page in the handout.